Hello everybody. In the best of times, 3D printing can be a pain. Now these are two prints that were done about 15 minutes apart. One of them looked okay, but it under extruded and fell apart. Now I couldn't figure out what was actually wrong with it with the printer. I'm guessing it was a filament issue. It's a cheap Chinese PLA. Probably all it was. Printed it again, worked perfectly fine. Now this is since I'm showing a print, this is a calibration, or not calibration. It is a tolerance test from Maker's Muse. Works pretty well. I suggest getting it. He's got an updated model. I think it's for $1. It's got, instead of having these keys, it actually has stuff built in to pop it loose. Because these are really annoying, but that's besides the point. But the purpose of this video is to go over how to set up the feeder unit, the feeder part of the printer, to send out the right amount of plastic. This printer is an ANET A8. It's got an E3D V6 clone, and it's got a Bowden tube. And this is kind of an important thing, so you don't waste a bunch of plastic, because you will be doing quite a few tests before you actually get it dialed in. This printer has been flashed with the Marlin 1.8 firmware, I believe. I know there's newer versions of it, but that shouldn't really matter. The things that matter is I can save to the eeprom with the M500 command. Some printers disable this for whatever reason. You have to flash it to get settings to be updated on it. In those cases, those type of printers that have that disabled, you're probably not going to have this issue because they're going to set that for you. Now, some printers don't save by the M500. You actually go in and update a configuration file. If you do the M500 setting, it'll actually sometimes do like a temporary file, like the Railcore uses the Duet Wi-Fi, and it'll save to some other file, and you can have some confusion with that. So I would suggest going in and actually edit the config file that's associated with that. Now, that kind of takes care of what printer I have, some of the caveats that you can have with that. Now, things that you're going to want to have to actually do this. You're going to need to have some way to send G-code. So in this case, I have it hooked up to a computer using the Arduino IDE. I can send commands back and forth. All that's good. A white PLA is my suggestion. In this case, I have a Bowden tube. I have the Bowden tube unattached so it doesn't waste filament. A heated hot end is required to actually feed filament. So making sure that's all set. Just kind of crossing your T's, dot your I's. Make sure if you're going to print, act like you're going to be printing something. So make sure the hot end is not next to your bed. If you're going to be, going to be feeding a bunch of plastic through. If you're going to want to feed plastic through, make sure you're 100% perfect. Go right ahead, but just make sure it's not like right next to the bed, because that can cause issues. So just do your due diligence to, not be dumb. The other thing you're going to want is a ruler. I have a 150 millimeter ruler. I use the whole 150. That way, if you screw up, I can kind of recover from it. You want a marker to mark your filament. I have white PLA, so black marker. If you have black PLA, use a silver marker. But I would make sure that it's a fine tip. It makes it a little easier to mark. The more accurate you are, the less steps you actually have to go through. Because this is not a do it once and have it perfect. You have to do it a few times before you actually run into, close enough to being perfect. I would say do it as best as you can. I wouldn't worry about being super 100% accurate. If you're off by half a millimeter, you're going to be doing it a few times until you get it close. I haven't had any issues with it not being 100% accurate. If I'm off by half a millimeter in the end, that's usually close enough for me. There's people that will want it to be more accurate, but they can make it more accurate. Now let's go to the computer side. Now, like I said, over here you can see my notes. This is going to be in the description once I get this all done. Now, the first step you want to do, make sure you can run the M503 command. Save everything that's here. Save it into a text file. If you screw something up, you got values that you can go back to. Now, the ones that we're going to be really interested in, the steps per unit and this E value. As you can see here, it's 102.96, but it started out as 100. Now, you're going to want to write down your initial value. And I would suggest maybe make a log. Write down all your values that you've tested, because you're going to be doing this a few times. That way, if you do run into something, you can kind of figure out what you did wrong. So, M503, that's your first command. M83, that's your second command. This puts the extruder into a relative positioning mode, so you can tell it E100 all day and it'll just spit out 100 millimeters of plastic. G1, E100, you can sit there and do that over and over again, make a mess, go crazy, but that's the next step you want to do. After you've marked your filament, you've written down your original value, your next step will be to send G1, E100, F100 to your printer. This will slowly push out 100 millimeters of plastic. It takes about 60 seconds to do this, so do that and then we can go on to the next step. Now we're going to want to get the original steps per millimeters. As you can see over here, this is steps per unit. Steps per unit, well, the unit is in millimeters, as you can see up here. So you're going to take your original value, which is, in my case, was 100, and times it by what the millimeters you're going to be sending it. So in this case is 100 millimeters. So my original steps per millimeters was, as you can see, 10,000. Now you're going to have to do this every time you get a new value for this E steps. So like, let's say if I started out from this point on, I would do 102.96 times 100. So this E value times the millimeters. So let's say you were doing it weird and you were doing it 50 millimeters instead of 100 millimeters. You know, one of these values would be 50, one of these values would be this E value. That's one of the things that the tutorials don't really, kind of drill into your head. They just kind of like show you a bunch of numbers and you have to figure it out. That's one of the things that you had to figure out. Now, I have some examples here. So like on your first run, let's say you got 99. Well, it under extruded. So your new E-step value, or steps per unit value, will be calculated off of the original value, which is 10,000. So it'll be 10,000 divided by 99. You will get 101.01. Out to 2 decimal points. That's all you really need. Come down here, take a look at the M92 command, which is the command that saves your steps per unit value. I should probably update that. Unit value. So that's what we're calculating here, your steps per unit. We told it 100, it went 99, so we're having to adjust the steps per unit. Save that with M92. Once you're all done, send the M503, and then you start the process over again. You measure out the 150 millimeters, you measure it out, you measure out everything. You send the G code again to send out 100 millimeters of plastic again, and then do it over and over again until your value is 0 or close to 0. You might want to do it one more time once you get the 0, just to make sure that it is actually 0 and that you didn't do a mistake on measuring. Now, when you're doing, like I said, once you're doing this, one value is E, the E value from that steps per unit. The other is the actual value of extruded filament, and then do your calculations off of that. Now, once you're all done, send the M500, do your saving. That should be all good. Now, I kind of want to show some examples of what I was doing for the calculations here. I started over a couple of times because I had some screw-ups. I actually thought I was under extruding when I was actually over extruding, so I had to start over. So now you can kind of see right here. So this one right here, this is my last value. So I did the calculation. Oh yeah, this right here. I had to screw up. I went the wrong way. Now, I did the calculation. I had 95.24 times 100. That gave me the new value. So that would be like this guy right here. I had 92.5 millimeters. It was right, the line was right in between. So it looked like half a millimeter. And that's the value I got. And now when I do the same thing over and over again, I actually get the spot on the 50 millimeter mark on the ruler. So I know that this is actually sending out 100 millimeters of plastic when I tell it to do 100 millimeters of plastic. Now, if you go through this and you screw up, like I said, make sure you save that initial value. Use that M92 command, E, whatever it was, and then save it, and you're back to what you had originally. Like I said, write down all those values. That last value, once you enter it in, do the M503, make sure it's saved, make sure it is your current settings. After you send the M500 command, it's a good idea to turn off the printer, turn it back on, and then run the M503 command again to make sure that everything has been saved. If you enjoyed what you had here, everybody says like and subscribe and hit that bell thing if it actually does work. I'm going to probably rarely post videos. It's going to be videos like this where I'll go through and do like a simple thing. So if you like this kind of thing, like, subscribe, ring the bell, whatever, and have a nice day.